we have solution that instead of having a piezometric tube, we have a U tube now. Now we have a U tube. This is a U tube. Now in this U tube, we have different manometric fluid. This is filled with some other fluid. In the previous case, where we had a piezometric tube, this piezometric tube was not filled with any fluid. This was filled with the fluid which was there in the container. Now, but only difference in the U tube manometer, we have a different fluid. So now we have a container A, and we want to know the pressure available in the container A. Now this container is connected to this U tube, which is filled with another manometric fluid, and we know the density of this fluid, we know the density of the fluid available in container A. After balancing, if this pressure A is more, then it will balance in this manner. If it is less, then it will balance in another manner, right. In this case, the left limb will have more height of this fluid than the right limb. Now if pressure A is more than the atmospheric pressure, then it will compress it, and this fluid in the right column will be more than the left column. So we have two approaches. Either we draw a horizontal line at this location which connects the same fluid, because it is connecting, this line is connecting the same fluid, this one and this one. When it is connecting the same fluid, then we can say that pressure at this point or pressure at this point, means pressure at the left limb of the manometer and pressure at the right limb of the manometer is same. So find out the pressure at this point, which is equal to PA minus, because PA plus, sorry, as we go downward, pressure increases. So what is the pressure exerted by this column of the fluid is equal to weight density of this fluid multiplied by height of the fluid. So PA plus gamma 1 H1. So PA plus gamma 1 H1, and what is the pressure at this point? At this point is equal to pressure at this point. Pressure at this point is equal to P naught, atmospheric pressure, and as we go downward, this column H2 will exert pressure, and that pressure will be equal to gamma 2, weight density of this fluid multiplied by height of this column. So P naught plus gamma 2 H2 will be the pressure at this point. Now these two are equated, we get one relationship, and with the help of that relationship, on the right hand side we know the density of the fluids and we know the height of these fluids. We can find out the pressure at point A. For another approach is, we start from A, and as we go downward, the pressure increases, and as we go upward, pressure decreases, and we will reach to this point where pressure is equal to atmospheric pressure. So we can use any method. The only thing that we have to keep in mind, that if we drawing a horizontal line, it must connect the same fluid on the left limb and right limb. So keeping these factors in mind and the concept of the pressure equation, we can write the equation which will give us the pressure in terms of the height of the fluid. So here what we are doing, we are starting from this point and we are reaching here. So what is the pressure at this point? PA. As we move downward, pressure increases, is equal to gamma 1 H1, and this pressure will be same as this pressure. So from here we are going upward, so minus gamma 2 H2 minus gamma 2 H2 is equal to 0 if this PA is a gauge pressure, means when we measure with reference to atmospheric pressure, this will become gauge pressure. Now this equation can be rearranged. PA is equal to gamma 2 H2 minus gamma 1 H1. So right hand side we have terms which are measurable, H2 and H1 can be measured in lab with suitable scale, and gamma 1 and gamma 2 of the fluids are known to us, we can find out the pressure. Now we have a U tube differential manometer in which we are trying to measure the pressure difference between 2 points A and B. Now these 2 points A and B are connected to U tube manometer having different manometric fluid. So in this case we have 3 fluids. One is filled here A having density gamma 1, another is a tube which is filled in this U-tube manometer having density gamma 2. Then we have another fluid filled in container V having density gamma 3. If we know these heights H1, H2 and H3, we can relate the pressure difference between these two containers A and B with the help of these column of the fluids. Whatever principle we have used in the last example, the same principle will be used here, and we will write the manometric equation. So, we are starting from point A. So, at A point, what is the pressure? PA. As we move downward from this line to this line, what is the height of this fluid? H1. So, pressure at the lower level means at this point will be equal to gamma 1 H1. Now, at this point and at this point pressure must be same because it is connecting the same fluid. So, from this point to this point the pressure decreases because as we go upward pressure decreases. So, minus gamma 2 H2, and from this point to this point as we further go up pressure reduces further, and that reduction in the pressure will be equal to column of the fluid multiplied by density of the fluid. So, this will be equal to minus gamma 3 H3 is equal to Pb. Now, this equation can be rearranged and we can find out Pa minus Pb in terms of the heights which are measurable. So, Pa minus Pb is equal to gamma 2 H2 plus gamma 3 H3 minus gamma 1 H1. Now, we can measure these H1, H2, H3 and gamma 1, gamma 2, gamma 3 are known to us. So, we can find out the pressure difference between A and B.